Greetings and welcome. Today we're talking about arithmetic sequences and series. So sequences, I suppose we should define some of these things first. A sequence is a list of terms. And later on in this chapter, we'll even be dealing with lists that are infinite in length. So it doesn't have to be finite. A series, I suppose, we're on a roll, is the sum. And that's not a good-looking sum. Blah. S-U-M, sum of the terms in a list. In a list. There we go. And then I suppose we should talk about terms are the particular numbers in that list.
Could you
So let's see.
slow down for a sec?
So
Zeb,
Yes.
if you don't get some of the stuff, it's going to be on.
I'm just trying to. I just want to get it all now.
8. Let's do 13, 18. So here's a sequence right here. And so with this sequence, just to give some notation, if I refer to a sub 1, that would be referring to the first term in the list, then a sub 2, a sub 3, a sub 4, etc. A sub n would be referring to the nth term in the list. Did I miscount? There you go. Yeah, a sub cinco there. So that's how you can reference particular terms. Another thing that would be valuable is trying to figure out the pattern in a list. So then we can do some work with it. And today we're talking about arithmetic. I know that word looks like arithmetic. It probably is. But I think arithmetic sequences that are arithmetic in nature, sounds more interesting. Arithmetic sequences are those in which each subsequent term can be found by adding or subtracting a common difference. All right. So in this case, our difference. What's the difference between each of these terms?
5.
Right. This seems to be adding 5, adding 5, adding 5. Right. Adding 5. So if I wanted to find out what the a sub 6 is, what would a sub 6 be? Maybe 23 plus 5, which is 28, right? 28. So the common difference is 5, all right? And that's denoted by the variable d, all right? 5. So I guess I could throw some proper definition there for you. So common difference is the difference, as in subtraction, between two consecutive terms. And I'll wait once I finish writing it. Consecutive terms in an arithmetic sequence. And specifically, it's I guess it'd be the latter minus the former. So the common difference would be like a sub n minus a sub n minus 1. Right? So the 5th term minus the 4th term, the 20th term minus the 19th term. Right? The 72nd term minus the 71st term. something like that. So common difference. So arithmetic sequences are not the only kind that there are. There are many different kinds of patterns that can exist, but today we're specifically going to focus on the ones that have repeated addition or repeated subtraction, figuring those out. So, and once I know the common difference, then it kind of unlocks the pattern, right, where I can find the 6th term, the 7th term, the 8th term, and so forth. However, what if I wanted to find like the 20th term here? It would be a little bit trickier. Let's actually look at this list, this same one. And see if we can derive a formula. Okay. So, so I might make a little chart here. Let's see. We'll have the term. Then we'll have the value of what's up. What's up? Oh, slow down. Slow down. Slow down, friend. So let's see. For a sub 1, right? A sub 2, a sub 3. A sub 4, and our goal will eventually be to get all the way down to a sub n. So for a sub 1, our first term would have just been whatever a was. Our second term would have been a plus the common difference. Our third term would have been a plus, well, two ways we could write it. We could call that a sub 2 plus the common difference, right? Or a plus 2d, right? If I add the common difference twice, it should give me a term 2 units away from the starting one, right? And then this would be a plus. So to find the nth term, how many d's would I add?
N minus 1.
N minus 1. You guys, how did you get that so fast?
We're just awesome.
It was amazing. Amazing. Right? So our formula, we just kind of discovered it from this pattern, is the following, right? So the nth term of an arithmetic, all right, is a sub n equals a. You could refer to that as a sub 1 if you wanted, plus n minus 1 times d. All right, so the first term plus some number of d's where it is 1 less than the number of terms I'm looking for. All right, so now we can, let's verify that this works. So if I wanted the 6th term here, I'm just going to fit it on the side here. So according to that, a sub 6 should have equaled 3 plus, if n is 6, so 5 times the common difference of 5. So 3 plus 25 is 28. And isn't that what we got when we did it without a pattern? That is. Right? So it appears as though that formula works. All right, so that's going to be the first thing we'll be interested in, is finding a particular term in a list, right? And that's going to be helpful for us. So let's do an example. So suppose this is my sequence. If I've got -4, -1, 2, and 5, dot, dot, dot. And let's say I want to find, I don't know, what is a sub 47 equal to? So the first thing we should do is let's label our variables. So there are actually 4 different values here. So I've got the nth term, the first term. N is the number of terms, right? Since I didn't specifically define that earlier. And D is the common difference for D. So so let's label what I know. So I don't know a sub n yet. A sub 1 is negative 4. N is 47 in this case. And what's the common difference? 3. And the common difference, we had that formula a little earlier. It is just the difference of any two consecutive terms, the former from the latter. So I could do the common difference by doing negative 1 minus negative 4 and getting 3. But I also could have done 5 minus 2 and gotten 3. Okay, so I just want to point that out, that sometimes you can do math a little bit easier to find the common difference if you wanted. Assuming I knew that it was arithmetic. Sometimes you won't know what kind of pattern it is, and you'll have to kind of figure out, oh, it's arithmetic, it's adding the same number each time. So now that I know all of this, I can just plug in what I know and solve for what I don't, which I guess what I haven't solved, right? It's already solved for what I don't know. So A sub 47 is going to equal negative 4 plus 47 minus 1 times 3. So that's negative 4 plus 46 times 3. Let's see, and what is 46 times 3? That's 18 plus 120, 138. 138. So it looks like 134. Nope. Would be our answer, right? So clearly that was probably faster than adding 3 repeatedly a lot of times.
46.
Yeah, 46 times, right? Probably quicker than like just doing like plus 3 and then hitting enter on your calculator 46 times, because at some point, right, depending on where you started, right? You could have started somewhere else.
Yeah, what if you encountered A sub 1 million?
Yeah, right? Like,
Yeah.
it wouldn't...
Yeah, at that point I'd get a robot just to press the enter button.
Right. Or having a formula can clearly be more helpful. And yeah, so anytime you're working with large lists of things, as long as there's a pattern, we can actually kind of sometimes calculate things a little bit easier. I forget. I think I did have to use, I think, this formula in some of my Excel spreadsheets before as a shortcut. Yeah, that's what it was. Was in Excel, I originally had a formula calculating by actually having like this huge list and having it calculate, and I realized that took up way too much real estate on my spreadsheet, and I was like, oh, that's terrible. Like, I want to just fit it all in a single cell. And I was able to use this formula within some other little functions going on, so that I didn't have to like have a whole spreadsheet just to calculate one thing. I could all just do it in one cell, and it worked a lot better, and it was more dynamic, because what happens if I didn't drag my spreadsheet down to the 200 value and I want the 200 and, first or whatever, So having formulas is definitely good stuff. So that is finding the specific term. Now, there's this concept of arithmetic means.
Hang on.
Okay. Where if I have specific, the terms, oh man, math people, they figured out the best way to say everything. I like this definition. The terms between any two non-consecutive terms. Oh, let's see.
Wait, the terms between any two
in n arithmetic.
Hang on.
Yep, I'll wait.
So just pause the video.
Oh, or I'll pause right here. So, what does non-consecutive mean? Not next to each other, right? Not next to each other, right? The geometric equivalent of that would be non-adjacent, right? So Vermont is non-adjacent to California,
I would say that is true.
right? And if I put the states in alphabetic order in a sequence, Vermont is also non-consecutive to California. So there you go, if it helps. So let's do an example of this. So find, let's say, 3 arithmetic means. Man, I'm not good at writing today.
Neither am I.
Arithmetic means, neither am I. Between.
Man.
Yeah, it's okay. If you don't get it.
And now this might be ugly. Let's see. Let me do 7 and
24.
Sure. Who knows how nice it'll turn out. It can be fractions, so I'm not too worried. So let's see. So what does this look like? Let me draw out what my little list would look like. So it'd be like 7 and then blank, 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 and 24. Okay? So what would help us, what one fact would help you find those?
Subtract. What I'd do is I'd subtract 7 from 24, then divide it by 4 to get the D.
That might work. Wow, I think that actually would work. And you're saying that D, the common difference, would be the thing that would help us, so then I could just add D, add D, add D, and figure out what those are, right? So using our formula, a sub n equals a sub 1 plus n minus 1 times D, I'm really interested in finding out what D is. So what could I do to find D? What do I know? I know a sub 1 is 7.
A sub n.
A sub, better yet, 1, 2, 3, 4, 5 is 24. And I think I just gave away what n is. 5. And I'm looking for the difference. Right? So classic algebra problem, right? Plug in what you know, solve for what you don't. Right? In case we didn't have the intuition of being able to figure it out. So let's do that. So I will have 24 equals, let's see, I don't know if that's really orange there. Let's see, I haven't had to select a good orange color in a while, so I'm out of practice. 24 equals 7 plus 5 minus 1 times D. And yeah, I believe his solution would have worked now that I'm looking at this. So we could subtract 7 from both sides. And I would get 24 minus 7 is 17. Yeah, this is going to be ugly, but that's okay. 5 minus 1 is 4. D. And then divide both sides by 4. And I will get D equals 17/4, right?
I got 4.25.
Can we pretend? Yeah, that's 4.25, yeah. If we wanted a decimal. Actually, that's not an approximation. That is exact in this case. Yeah, so...
Decimal exactation?
Yes. So let's see. So 7 plus 17/4. Right? Right, so what I'm going to do to find these is just add the 17/4 to each of these. And I love the ones that look hopeful, like, oh, wow, this is going to be easy. And then, like, they're the ugliest answers in between.
If
Yeah.
it was 23, it would have been beautiful. But it wasn't.
It's the way it is. So let's see. 7 firsts plus 17/4. That's what, 28/4 plus 17/4. So that's 38, 35/4, is it?
45.
Yep, thank you. 45/4. And now that I'm working in the realm of fourths, I don't need to find common denominators anymore. 45 plus 17, so that's 55 plus 7. Is that 62/4?
Yep.
Which I guess technically reduces, but I might wait a moment before I reduce it since I'd rather keep it in fourths. Don't reduce it? Well, for the sake of...
Reduce it to a half. That'd be it.
Right. But for the sake of adding this in my next step, I like the fact that it's still in fourths. So let's see. What is it?
79.
79/4. And just to verify, what do I get when I add another 17/4 to that? 96/4.
Yep.
And is 96/4 equivalent to 24?
Yes.
I believe so. And if I did reduce this, this would have been 31 halves, right? So just want to point that out. So I'm actually able to find numbers between a list if I know my, some starting number and I know some ending number and I know how far out that ending number was. So that's pretty cool. Pretty cool. So the last concept we've got, right, and we'll have all sorts of problems using these formulas inside and out. But this is the last problem we got, which is, I guess I'll call this partial sum of an arithmetic, I guess. Nth partial sum. Now, the weird thing, so as I said earlier, a series is the sum of a list. And the thing that always throws me off is that a series sounds plural. But a series is not going to be a list, like a sequence is. A series is a number, which is just the sum of that list. Okay? So that always kind of threw me off, the plurality sound of it. And actually, an infinite list, you would perhaps think at first, right, consideration that if I add together all of the terms in an infinite list, that it couldn't be anything other than infinity, or maybe negative infinity, right? But it turns out that we will be calculating in a few days the sum of infinite lists that are equal to a specific number. So I could have an infinite list that adds up to 2. Which is weird.
That doesn't make any sense.
Yeah. It takes a little while to get used to, but you'll believe me when we get there. At least I hope. I hope. So, so what I mean by S sub n here is a sub 1 plus a sub 2 plus a sub 3 plus ... all the way out to the a sub nth term. Okay? So that's what I mean by this. I was considering drawing like a visual representation of this, but I kind of really like the arithmetic proof of this. Yeah. Yeah, let's prove that. Yeah, I've got time. Yo tengo tiempo. So my goal is that I'm eventually going to get just a formula equals some formula, all right? That I can just calculate the sum of an arithmetic list instantly, right? That would be wonderful. So let's do this. Should I try the visual? No, the visual would just take me too long to draw. So let's consider this. So S sub n, let's do a proof.
That's kind of weird to say.
S sub n?
Yep.
Maybe. Discovery. Let's prove this. So S sub n would equal a sub 1 plus a sub 1 plus d, right? That's my second term. You guys agree?
Yeah.
Plus a sub 1 plus 2d
Plus a sub 1 plus 3d.
plus, and then the last term is a sub n.
A sub 1 plus n minus 1.
Actually, let me see if I can shift this over because I'm going to run out of room here. Yeah. I can't. It's going to copy that. Oh, did I get it? I'm going to need a little bit more space. Such a cheater. Here we are. So, so here we go. So let's see. The very last term is a sub n. What would the term before a sub n be?
A sub n minus 1.
So a sub n minus 1, right? And what is a sub n minus 1 going to be in terms of a sub 1 and d?
Couldn't you replace the
A sub 1 plus.
with just d itself?
Wait, what was the question?
Never mind, that doesn't mean
Or actually, this
A
is
sub 1 plus n minus 2d.
right. So I could consider it a sub 1 plus n minus 2d, right? Right? The other way I could define it, what if I define it from in terms of a sub n?
A sub n minus d.
A sub n minus d, right? If I use the common difference backwards, I could also write it as a sub n minus d, right? And then what would the term right before that look like?
A sub n minus 2d.
A sub n minus 2d, right? So I can not only find numbers in my list by adding the common difference and moving to the right, but I could also subtract the common difference and move to the left. Now watch this. I am going to add two equations together. And I'm going to actually add this equation to itself. And you guys know from solving systems of equations back in Math 4 that you can add two equations together and still be given a true statement.
Hang
right?
on, wait. Where did a sub n minus d come from?
That's one.
It's one term before the last term, is what that is.
Because if you add d to
Why
that,
do you
you
want
just get
that?
a sub n.
We'll see. We'll see.
Wait, what's the plus for
What's the plus where?
the white plus?
Oh, I'm adding two equations together. So I'm going to add this to itself, but I'm not going to add it to itself in its current order. I'm going to flip-flop it on itself. So I'm going to add this term is now going to be the first term, and this term is going to be the last term over here. So it's the same thing. I'm just changing the order, right? Commutative property of addition. I'm allowed to do that.
adding to subtract.
So I'm going to add here a sub n minus d. I'm going to add here the a sub n minus 2d that we talked about, right? Third to last term. And then I'll plus ... plus. What one would I add with this one? What was that would be this term is now the second term is now the second to last term. So this would be a sub 1 plus d, right? And watch what I end up getting. This is kind of a cool trick. So Sn plus Sn is how many Sn's?
2s.
2 S sub n's. A1 plus An is just A1 plus An. What happens when I add these two together?
A1 plus an.
Right, the d's cancel out, and I get A1 plus An.
A1 plus an.
Plus the two d's and the negative two d's cancel out, and I get A1 plus An. Plus, what happens here?
An plus a1.
An plus A1, or we'll call it A1 plus An. And what's this?
A1 plus
A1 plus An. And now question, how many A1 plus Ans are there?
n.
Could you explain that?
Well, there are n terms in that sequence.
Yep, so there are n in this. And so this list was n long, and now since I've just kind of combined them vertically, it's still n many long. So what's another way I could write that?
A1 plus an times n.
Right, or I'm just going to write it as n times A1 plus An. Right, n many of them, repeated addition can be written as multiplication. And what if I want to solve this for S sub n for some arbitrary reason, like having a formula that will give me the sum of a finite list? Divide by 2. Wow, isn't that nice? So it turns out our formula that we just derived is S sub n equals n over 2 times, bless you, a1 plus an. And I'll also write that up at the top. So that's n over 2 times a1 plus an. So all I have to do in order to find the sum of a finite list that's arithmetic is add the first term and the last term, multiply by the number of terms, and divide by 2.
Do those ends have to be equal to each other?
Yeah, this n, and this n are all equal, yeah. So the sum of the first 7 terms, n would be 7, and I'd be adding the 7th term to the first term. So let's do some work with this. I think 2 examples will suffice, and then we'll be golden. Man, this is great. Yeah, we're almost done, though. We're going to do it, guys. That's what I'm surprised about. So example, find...
all shadows from.
Yep. Find the sum of the first 60 terms. And suppose this is my list. Suppose I've got 9 plus 14 plus 19 plus ...
You like 5.
Mm-hmm. Plus 304. So I'm assuming that this is the 60th term. Excellent. Good news. So to find the sum of this list.
No, yeah, 3 or 4.
All right.
So wouldn't it be 3?
So what do I need to find the sum? So S sub 60 is going to equal, what facts do I know? Let's see. Actually, I guess I could write that after. I know the first term.
How do you know
60, then you can put 60
300?
for every n in your page.
How do you know 304 is the?
They gave it to us.
Okay.
They gave it to us.
You know that A1 is
A1 is 9. A sub 60 is 304. What's the common difference here? And better yet, do I need it?
No.
No. Because our formula actually excludes it, right? I don't even need to know what the common difference is. I just need to know that there is one. But the common difference here, 14 minus 9 is 5, right? So let's plug this in and just solve it. So S sub 60 is, it would be 60 over 2 times 9 plus 304. So that's 30 times 313. So what is that going to be? 3 times, let's see, that'll be 939 with an O. Bam, we just found the sum of 60 terms, and we didn't even know all of them. It's pretty cool stuff.
Wouldn't you just box in the 9, 3, and 18?
Eh.
Is that the answer?
Well, but I wanted to find S sub 60. I should label my answer. Now, I'm not going to do this problem, but I just want to point it out. I could give you, what if I gave you the start of a list? 1 plus, what if I wanted to figure out this? 1 plus 2 plus 3 plus ... Well, actually, that one's too easy.
Hang on, I'm all out of room.
Yeah, I am too. So don't worry. We're not writing anymore. So suppose, all right. Let me make something up then.
You have to use the first part.
Let's do 1 plus 3 plus 5 plus ... right? And I don't know the last term, and my goal is to find S sub 100. So I want the sum of the first 100 odd numbers, okay? And now what Joe said is exactly right. The thing we would do, step 1, we would want to find A sub 100, right, using our first formula. And then once I did that, I would find S sub 100. Okay, so I just want to point out, even if you don't know the first term or the last term that you've got in your list, you can find it using our first formula. As long as we know the common difference and stuff like that, we can go from there. All right, so that's just a general outline. So well done today, everybody. We did it. And now we're definitely going to have some partner work in just a moment. So thank you.